Okay, first lesson is about angles and angle measures. So the first thing you need to know is what is the definition of a radian. So it is a measurement of the central angle that would be subtended in a circle by an arc length equal to its radius. So the measure of this angle right here would be 1 radian, because it's subtending an arc length that would be equal to the radius of that circle. So if we think about the formula of circumference, which is 2 pi r, then we would understand that 360 degrees would then be equivalent to 2 pi radians. And then we have this as a conversion, that pi radians is equal to 180 degrees in a circle. Okay, so using that, we're going to be converting. So let's take the first one here, 30 degrees. Okay, so to convert that into radians, we're going to times by pi and divide by 180 so that you can see that the degrees will end up canceling. And so the first thing you could do, this is a special one, so 30 degrees, you could reduce the 30 and the 180, divide each by 30, and you would get pi over 6. Okay, so you could leave it in that form, or pi over 6 is 0.524 radians. Okay, but we're going to leave that one in that form. Okay, negative 120 degrees. So again, we're going to times by pi and divide by 180 so that we get the degrees to cancel. We end up in radians. So 120 and 180, you could divide each by 60. So that would be negative 2 pi over 3. Okay, 25. So we're going to times by pi, divide by 180, and we could convert this to decimal form, so I'll give you decimal form. Or dividing by, what do they both divide by? 5. So you could have had negative 5 pi over 36. Okay, and 213 degrees times pi over 180. So we're going to times by pi, divide by 180, like so, and I get 3.718 radians. Okay, so if you you think about what does pi equal? And pi equals approximately 3.14, okay? And you think about pi is that angle right there, right? And then you know that where 213 ends up, right? Because this is past 180. So you kind of have an idea that this number is going to be slightly bigger than 3.14, right? That also should connect in your mind. You should have that little bit of a reference to, or does my answer make sense? Okay, so 1.2 radians. So again, we kind of know where that is. We know that 3.14, right, is that. So 1.2 is quite a bit smaller than that. It's not even halfway. So I'm guessing that my angle is in this quadrant 1. Okay, so when I convert, I'm going to times by 180 degrees and divide by pi radians so that I get my radians to cancel. So 1.2 times 180 and then divide by pi. So I get, and my prediction was right, 68.755 degrees. Okay, same thing, we're going to times by 180 and divide by pi to get into degrees. Well, that cancels. So 7 times 180 divided by 6 equals 210 degrees. Okay, and the last one, or sorry, not the last one, 2 more here. 2.57, so times by 180 divided by pi. So this is 147.250 degrees. And the last one, same thing, times by 180 divided by pi. And you get 171.887 degrees. Okay, so that's conversions. So degrees to radians times by pi over 180. Radians 2 degrees times by 180 divided by pi. Okay, next we're going to talk about coterminal angles. Okay, so 40 degrees. Where we're going to draw that? Right about here. So there's a 40-degree angle. So if I want to give another angle that would land right in that spot, if I'm here and I rotate 360 more, I end up there again. So you would add 360, and if you had an angle that measured 400 degrees, you would have to go around and land right there again, same spot. Okay, and another way, because I asked you to do a positive and a negative, now you could go from here and rotate all the way backwards 360. So negative 320 would also be in that exact position. Okay, now I have 8 pi over 3. So where does that lie? So you could take that conversion if you would like to, times by 180 over pi. So 8 times 180 divided by 3. So 480 degrees. Okay, so where does that lie? It lies in quadrant 2. Okay. Now, we're doing the same kind of thing, but let's not use this degree measurement. Let's use our radian measurement. Okay, so I'm going to take off a full circle. So a full circle is 360, but in radians, a full circle is 2 pi. Okay, now I'm going to actually convert that into 6 pi over 3. Okay, I just did a common denominator. So I end up with 2 pi over 3. So that's a coterminal. And I could also rotate forward a full circle. So 8 pi over 3 plus 2 pi. Okay, so that's really what you want to do. Same thing we did here, plus minus 360. Here we're going to plus minus 2 pi because that is a full circle. So this is 14 pi over 3. So those are some coterminal angles. Okay, so same thing, but 360 in radians is 2 pi. So how do we write that in general form? So you could have had 40 degrees plus 360k and indicate that k has to be an integer. And the other way would be 8 pi over 3 plus 2 pi k, and k is an element of all the integers. So we could make one full rotation, we could go 2 rotations and land back, 3, 4, we could go -1 rotation, -2 rotations, but you'll always be in that same position. Okay, and we're going to talk about arc length now. So arc length in a diagram would be if you have a circle and you have a certain angle, the arc length would be the measure of that amount of the circle that you're going to cut through. Okay, so you can see that it's just a fraction of what your total circumference would be then. Okay, so we know that circumference is 2 pi r. So let's just say that, what if I wanted the arc length from here to here, right? Well, you know that that's just a quarter of the circumference, right? So in other words, then this arc length would be pi over 2 times your radius. Okay, now it's neat to see that I know that pi over 2 is equivalent to that angle. That's 90 degrees, pi over 2. So what this formula is that it ends up being that the arc length equals the measure of the angle in radians, because pi over 2 radians is the measure of that angle, times the radius length. So that's the formula, and this is representing the arc length. Okay, a minute hand is 4 centimeters long. So we know our radius. What is the arc length it goes around after 5 minutes? Okay, so 5 minutes, we got to figure out what degree measurement that is. What's the angle? Okay, so would it make sense? It's kind of our diagram, right? So 5 minutes is 1/12 of the way around a clock, right? Does that make sense? So 360 degrees over 12. So 30 degrees. Okay, so we need to say the arc length is the measure of the angle in radians. So 30 times pi over 180, that's our conversion, times the radius of 4. Okay, so this ended up being pi over 6. So when you convert the 30 degrees to radians, so pi times 4 divided by 6, and your answer is 2.094 centimeters. That's your arc length. Okay, number 2. How many degrees are subtended by an arc length of 15.201 millimeters if the radius is 6.7 millimeters. Okay, so now I know my arc length, and I know my radius, so what is the angle measured? Okay, so this time I'm going to plug 15.201 into that spot, equals the angle times the radius. So I'm going to divide 15.201 divided by 6.7, and you get 2.2688. That's radians, but I'm asked for how many degrees, so I'm going to take that radian times by 180, divide by pi, and I get 129.993 degrees. Okay, that's lesson 1.